We're starting our review with some derivatives. So number one, we have an exponential function, something of the form y is equal to a to the x, or similar to y equal a to the x. The derivative of this is y prime is equal to ln a times a to the x. Okay, here we want to take the derivative, so we have y prime is equal to, and first a ln 3 comes out, that's the base, 3. And then we have 3 to the 7x squared plus 5. And here we're going to do a chain rule and multiply by the derivative of 7x squared plus 5, which is 14x. Okay, number two, let me remind you of the derivative of arctan if y is equal to arctan x. Y prime is 1 over 1 plus x squared. Alright, so we're going to use that over here. So here we have y prime is equal to 1 over 1 plus this expression squared. And now we'll do the chain rule multiplied by the derivative of this expression, which is 35 x to the 6th. In number 3, we're going to do an implicit differentiation because we have y on the left and on the right. Okay, let me remind you of the derivative of arcsecant. Okay, y prime is equal to 1 over absolute value of x, square root x squared minus 1. Alright, so we're going to use this with a chain rule. Alright, so on the left we have y prime, and on the right we have 1 over the absolute value of x minus y, and then we have the square root x minus y squared minus 1 times the derivative of x minus y, which is 1 minus y prime. So I'll multiply by 1 minus y prime. Okay, now the hard part really is solving for y prime, so we're going to do that. I'm going to do that over here. So first of all, let's split up this quotient. So we have y prime is equal to 1 over absolute value x minus y times that square root minus y prime, absolute value x minus y, and that square root. Okay, now we want the terms with y prime on the same side of the equation, so let's bring this second term over to the left-hand side. Okay, so we have y prime plus y prime over absolute value of x minus y times the square root is equal to the first term Okay, now the second to last step is always factoring out the y prime, so we'll do that here. So here we have 1 plus 1 over absolute value x minus y times that square root. And just copy over the right hand side. Okay, now just divide by the brackets on both sides, and that will solve for y prime. So we have y prime is equal to, this will be the numerator, and the denominator is that bracket. Okay, this is a a mixed quotient or a complex fraction, we could leave it like this, or we could simplify if we multiply top and bottom by this denominator. So let's do that just to make it a little bit simpler. Okay, a little bit more compact. Okay, so if we do that, we have on top, multiplying by this denominator, on top we just have 1. In the denominator we have here x minus y square root x minus y squared minus 1 plus, we multiply the second term by the denominator, so we have a plus 1 there. Okay, so that's a more compact expression for y prime. In number 4, we want to take the derivative of an expression that has x in the base and x in the exponent. So we must use log differentiation in this case. That'll just bring down that x expression in the numerator. So we start by taking the ln of both sides. So on the left we have ln y is equal to ln x to the 5x cubed plus 7. Okay, or ln y is equal to, bring down the exponent, 5x cubed plus 7 times ln x. Okay, derivative of the left, with differentiating implicitly, that would be y prime over y. And on the right, we're doing a product rule, so we have the first times the derivative of the second plus the derivative of the first, that's 3 times 5 is 15, 15x squared times the second. Okay, and now just multiply, we want y prime, not y prime over y, so multiply both sides by y. So we're going to have here y times this whole expression, and I'll write the what y is equal to in terms of x. Okay, so here we have x to the 5x cubed plus 7 multiplied by the line above. Okay, number 5, we're differentiating a log expression. So let me just remind you, if you have y equal to the log base b of x, y prime is equal to 1 over ln b times 1 over x. Alright, so we're going to use this with a chain rule to differentiate this expression or this equation. Alright, so we have y prime is equal to, and here we have 1 over ln 7, and we have x squared plus 2 in the denominator, and now we have to multiply by the derivative of x squared plus 2, so that's a 2x in the numerator. In number 6, we're going to differentiate using the product rule. So we have y prime is equal to the first, that's x cubed, times the derivative of the second, so here we have e to the 5x times the derivative of 5x, that's 5, plus the derivative of the first, that's 3x squared, times the second.